Hi, my name is Daniel and my teammates are Alejandro and George. We're going to present about the third degree polynomial functions and well, let's start. What is a polynomial function? A polynomial function is a function whose rule is given by a polynomial in a variable. This means that any equation that has an x and has more than one term can be a polynomial function, like this one over here. This one is an example. However, third degree polynomial functions are more complex than what you think. These functions are determined by what's called the degree of the equation, which is the highest power of x. In these types of equations, 3 is the highest power of x, like you can see here. And an example would be this one.
To understand more about the cubic functions, we have to know their properties. First of all, a, b, c, and d are always real numbers, and a can never be zero. The domain and the range of the function belong to a set of real numbers. The y-intercept of the graph is given by f 0 equals d. The x-intercept are solved by equaling the equation to 0. But to start solving them, the equation has to be in the standard form. The standard form is ax cubed plus bx squared plus cx plus d. An example is x cubed plus 8x squared plus 19x plus 12. Then a is 1, b is 8, c is 19, and d is 12. This is the equation that we are going to solve today.
Yesterday in math class, Patrick was given a certain cubic function. He was asked by the teacher to check if this function could model the volume of a rectangular prism. The function given was the following. Can this function be used to model the volume of a rectangular prism? Why?
So now we're going to learn how to solve this example. So first you need to get the factors of the d, which is the last number. So 12 can be divided by 1, 2, 3, 4, 6, and 12. And all of these values are going to be plus and minus. So these values are going to be called p. Then you need to get q. Q will be a in this equation. So q will be just 1. When q equals 1, you don't need to change p values and you can use them to try and get a solution. Okay, so with these values, we're going to try and plug them in a synthetic division so we can solve this equation. Okay, so let's try it with -1 first. So to solve the synthetic division, you need to put the values a, b, c, and d first, and the value that you're trying of p, which in this case we'll try with -1. Okay, so first you just pass 1 right here, and then you are going to multiply 1 times -1, which is -1, and you are going to do the same for all of the next values. So here you're going to subtract 8 minus 1, which is 7. You're going to multiply 7 times -1, which is -7. 19 minus 7.
Now we have to factor the equation that we got from the synthetic division. To factor, we have to find two numbers that multiplied get 12 and added get 7. Those numbers are 4 and 3. Then we equal the equation to 0 and then we solve for x, and we got the other two results that are -4 and -3.
So now we're going to show another way that you can solve third degree polynomials or cubic functions. So to do this, we're going to factor by grouping. This is an easier example because in the first example it was too hard to factor by grouping. So here you just group the first two terms and the second two terms in two groups, and then you're going to factor each group by common factor. So after you get the common factor, you have to get the same result in the parentheses. So with these two results, you make one group, and with the remaining two results, you get another group. So this group is already factored completely, but this second group you can refactor it. So you're gonna factor this one by difference of squares. So you're gonna get x minus 3 times x plus 3. And after you get these two results, they're already factored completely, you can get the three solutions. So you just equal the three parentheses to 0, and you solve for x in each case. So the three solutions in this equation are 3, minus 3, and 4.
Since the three solutions of this equation are negative, you cannot model a rectangular prism, since volume cannot be negative.
So now we are going to learn how to graph cubic functions. These ones are the steps. First, you have to find the x-axis intercepts by setting y to 0 and solve for x. Then you have to find the y-axis intercepts by setting x to 0 and solve for y. And finally, you have to select the critical x values and plot additional points.
So what does these steps mean? Okay, so first we have to find the x-intercepts, and we do this by setting the equation to 0. This is the same that we did to find the solution, so we got that step done. Okay, so the second step is to find the y-intercepts. And how do we do this? By setting the x to 0. So okay, so if we set the x to 0, we got everything multiplied by 0. So the y-intercept would automatically be 12, or d. Now we got that step done. So now we just have to select critical x values and plot additional points. So to do this, we have to first plot the points in the graph. So we have that it's minus 4, minus 3, and minus 1. Okay, so we're gonna make a little bit more here. So minus 1, minus 3, and minus 4. So we know that the graph of the cubic functions is a little bit like this. So we have to select critical values and find the value to make this shape. So let's try with minus 2. So we just plug minus 2 in the equation. Okay, so now after we plug minus 2 in the equation, we get that for the point in the x that is minus 2, we get the point in the y that is also minus 2. So now we're going to plug this coordinate in the graph and follow the basic shape of the cubic functions to graph the example. So we put the point here and we follow this kind of shape. So it's going to be something like this. And now we got that this graph is the same as in the example.